Okay, let's look at an example. This is an inventory control problem, right? It says that the pharmacy has a uniform annual demand for 200 bottles of certain antibiotics, right? And it costs $10 to store one bottle for 1 year, and it costs $40 to place an order. And the question is, how many times during the year should the pharmacy order the antibiotics in order to minimize the total storage and the reorder costs? All right. So let's let x to be. So x is going to be the number of ordering. So number of orders per year. All right, then we want to set up a cost function, so I'm gonna call it the C of x. All right, so there's gonna be a reorder cost, so I'm gonna just say, so we have to figure out what that is. Reorder cost, and then it's gonna be there's a storage cost. All right, so since we make x orders per year, and each order costs $40, so the reorder cost would be $40 times x, right? And the storage cost is a little tricky, right? So since they have a uniform annual demand, so you can think of it this way. So let's say this is time t. Let's say you make an order here. Right, so since we're gonna make x orders per year, and we need 200 per year, so each time we're gonna order 200 over x bottles, right? And here's next order again. We order 200 over x bottles there. All right, then since we keep on selling them, so the number of bottles stored will decrease, and by the time you make the next order, it becomes 0. So on the average, we are storing 1/2 of the number of ordered bottles. So it's going to be, on the average, you have 100 over x bottles stored. So that's on the average, right? On the average, we are storing 100 over x bottles. All right, so then we can compute it. Let's say storage cost. All right, so we have 100 over x bottle is stored on the average, and each bottle costs $10 to store, so you multiply by 10. All right, so if you clean that up, you're gonna get function C of x is 40x plus 1000 over x, right? So this is a cost function. If you want, we can probably write it as 40x plus 1000 x to the negative 1. I like this form when it comes to taking the derivative, right? So what we want to do is we want to minimize the cost, not maximize. So we want to minimize the cost, and on the interval, so I guess we're gonna start from 1, because since we have to at least order once a year, so then you can probably order as many times you want, right? All right, so this is the function we want to minimize. So let's find the derivative to find a critical number. All right, so take the derivative. c prime of x is equal to, right, derivative of 40x would be 40, right? Then derivative of 1000 x to the negative 1 would be negative 1000 x to the negative 2, right? Which can be written as 40 minus 1000 over x squared, right? So I'm gonna set that equal to 0, right? And first we can add 1000 over x squared to both sides. So you're gonna get 40 is equal to 1000 over x squared, right? Next step would be, I don't like fractions, so I'm going to multiply both sides by x squared. You get 40 x squared, which is equal to 1000, right? Then we can just divide through by 40. So x squared is by itself, and 1000 divided by 40 is 25, right? And which means that critical numbers are x equals plus or minus square root of 25. So we're taking a square root of both sides, which is 5, right? But remember that we're talking about the number of orders, so you know that the negative numbers are not going to be involved. So we are just going to look at the positive 5, right? So positive 5 is the only critical value on that interval there, right? So we think that this is going to give you a minimum, but we have to make sure, right? So we're going to take the second derivative and do a second derivative test, right? C double prime of x is equal to, right? So we take the derivative of this guy right here. Derivative of 40 is 0. And derivative of negative 1000 x to the negative 2 would be 2000 times x to the negative 3, right? Which is going to be just a 2000 over x cubed, right? So let's plug in x equals 5. So second derivative evaluated at 5 is 2000 over 5 cubed, right? But all we want to know is if it's positive or negative. In this case, this is definitely positive. By the second derivative test, we know that the c of 5, right? So this is concave up, so we're looking at the minimum. So this guy is the, maybe I should go down here, right? So this tells you that c of 5 is the absolute minimum, right? Which is what we're looking for because we're trying to minimize it, right? So that the number of times we should order a bottle of bottles of antibiotics is 5 times a year. So 5 times per year, right? This will minimize the total storage and reordering cost. All right, that's it. I hope that this was clear.